So this video discusses about the direction cosines of a vector and also normalization principle of the direction cosines. So what are the direction cosines? Let's say we have three-dimension coordinate system. Let's say this is a three-dimension coordinate system. And you understand this is z-axis and this is y-axis and this is x-axis. Now let's say we have a vector. Let's say this is a position vector, and let me call it as a vector A. And let's say the components of the vector A are given as, let's say, ax, ay, and also az. Let's say these are the components of the vector A. Now, what are the direction cosines? Direction cosines, these are the angles in which a vector is with respect to the axes. Now, for example, with respect to the z-axis, the angle is basically given as this angle, and it is being symbolized as, given as gamma. And the angle with respect to the y-axis, it is basically given as this angle, and it is being symbolized as, should be that of beta. And the angle with respect to the x-axis should be this. The angle with respect to the x-axis, it is given as this angle, and basically it is symbolized as, and that should be alpha. These are what you call directional cosines. Now, how do we find the directional cosines? So, directional cosines are calculated as, the cos of, let's say, angle alpha, that is the angle with respect to the x-axis, is given as, what is the x component of the vector? We have it as ax, and I divide by the magnitude of the vector A, which is given as that. And likewise, the angle with respect to the y-axis, that is given as beta. We have it as, what is the y component? We have it as ay divided by the magnitude of the vector A. And also the angle with respect to z-axis, we have it as a cos of, a gamma, that is given as az divided by the magnitude of the vector A. So this is how the direction cosines are calculated in that way. So what is the principle of normalization? So now the principle of normalization, it follows the principle of it follows the principle of the unity vectors. So according to the principle behind the normalization, it states that the cosine square of angle alpha plus the cosine square of angle beta plus the cosine square of angle gamma is equal to 1. This is what we call the principle of normalization. It can be used to have, if we have two angles, we can be able to find the other angle using the principle of normalization. Let's say if we have this angle, we can be able to find this angle if we have this angle, and likewise. So that is what we call the principle of normalization. Always, direction cosines obeys the principle of normalization. Let's say we have this case. Let's say we have a vector, let's say a vector A, and that is giving us 2i and plus, let's say, 3j, and that is plus 4k. So what are the direction cosines of the vector actually a, and determine if the principle of normalization is being obeyed or not. So first thing, we are going to have the magnitude of the vector a, that is the square root of x squared plus y squared plus z squared, that is the same as 4 plus 9 and plus 16. So what is the magnitude of this vector? We have it as a square root of 29. The next, we're going to start with the cosine of angle alpha, which is the angle with respect to the x-axis. So what is the x component of the vector? We have it as 2 divided by the square root of 29. So in this case, we'll be able to have the angle alpha. What is the angle alpha? We have it as 68.2 degrees. That is how you should have to get it. And how about the angle with respect to the y-axis? And that is given as beta. So now how about the angle with respect to the y-axis? So have it as cos beta. That will be given as, what is the y component? We have it as 3 divided by the square root of 9. It should be 29. And of course, you know, angle beta will be given as 56, 0.1 degrees. And finally, we have to calculate cos of angle, and that should be gamma. That is 4 divided by the square root of 29. And the angle gamma will be calculated as, now we'll have it as 42.0 degrees. So now this is how the direction cosines are actually calculated. So let's see if these angles are obeying the principle of normalization. So what is the principle of normalization? It is this, that the cosine square of angle alpha plus the cosine square of, should be angle beta, and the plus the cosine square of angle gamma is the same as 1. What is cos theta? We have it as 2 divided by square root of 29. That is to the power 2 plus, what is should be cos beta? I should say cos alpha rather. We have it as that. And what is the cos actually beta? We have it as, we have it as 3 divided by a square root of 29 to the power 2, and the plus, what is the cos gamma? That is given as 4 divided by square root of 29 and that to the power 2. And see if it is really equal to 1 or not. But that's the principle behind that's the principle behind the normalization principle. You see that it will be really equal to 1 if that's the case. Now here's the task for you. Try to have the direction cosines of the following given vectors. Try to have the direction cosines of the following given vectors and see if the principle of normalization is also being obeyed as well. We have, let's say, a vector u that is being given as, positive I plus 2j minus, let's say, 5k. And let's say we have a vector v that is given as 5i plus 6j minus, let's say, 7k. And let's say we have a vector m that is given as, let's say, negative 7i plus 2, let's say, j plus 6k. So try to have the direction vectors for these, try to have the direction cosines for these vectors and determine if they if the principle of normalization is actually being obeyed. So here's the question for you. When do you expect actually direction cosines when do you expect that the direction cosines cannot obey the principle of normalization? So I want to see some responses in the comment section below. Thank you.